have a look at this one. So rate of change. Have you heard about that? Yes, you should heard about that. Okay, rate of change is kind of gradient. Okay, rise over run is one of the examples of rate of change. What else? Speed. Okay, acceleration. They are all rate of change. One of them is velocity. Okay, can be denoted like x dot velocity, y velocity, change of the displacement, change of the time. Okay, say I go to any place to, there's 300 kilometers. It takes 3 hours, so it's 100 kilometers per hour. That is the velocity. Okay, so we're going to use this one. Acceleration. Acceleration is rate of change of the velocity. Okay, rate of change of the velocity. Therefore, it comes from rate of change of the displacements. It's coming from again. Okay. But in 4-unit mathematics, we will very rarely use this formula, but we use this formula mostly. Okay, acceleration is the rate of change of the velocity, and that can be denoted like still dv divided by dt, but we can put some common thing like dx and dx here. Okay, nothing changed, but dx divided by dt was the velocity. So you can write this as the velocity like this one. Okay, so that is the one of the formula you guys have to remember. Okay, so see what the question is like. So we have a kind of acceleration in the question, and then the question is asked to find what is the velocity in terms of displacement. Then you have to use this formula. Okay, and then some questions say what you can kind of find the relationship between the velocity and the time. Then you have to use this formula. Okay, it's highly depending on. One other thing that you have to remember, well, guys, still, I'm not talking about 4-unit mathematics, still 3-unit math. So here, the velocity can be denoted like here, okay? So can you see that? V squared divided by 2, differentiate, will be V. So therefore, you can rewrite V as this one. Can you see that? Then, guys, we can cancel dV and dV. So finally, you can write like this one, okay? So look at this. We have 3 formula that you have to remember. Sorry, guys, you have to remember. Okay, there's not many things to remember, but this is just one of that very, very little number of formula. Okay, so acceleration can be replaced by this or this one, highly depending on the question. So your reading skill of the question is really required. Okay, you have to peruse the question. Say again, if the question is related with velocity and time, yes, you need to replace this by the acceleration. And if the question is related, find out an expression regarding to the velocity and the displacement, yes, you have to use this formula or this formula. But mostly, my experience was saying this is little more used rather than this one, but it doesn't really matter. Okay, so we are ready to go ahead in doing the real 4-unit mechanics. The other one, guys, according to this, all of the letters and formulas over here, so they're all little letters. So little v, little x, little t. So they are pronumeral, which means they have, these letters are representing the numbers which are changing. Okay, the time may change 1 second, 2 seconds, 3 seconds, 10 hours. Okay, so it's pronumeral. And velocity, can be 10 meters per second, 20 meters per second. They're always changing. But if you see the question like, capital V, that's the constant velocity. Okay, that's constant velocity. If you have a small v, pronumeral velocity, capital V, what question will say about that? The capital V is this constant or fixed value for the velocity. This capital V usually being used for representing the initial velocity of any kind of particle, movement of any particle. Okay, so this is very basic of the topic. Okay, so I am pretty sure you guys have a good feeling about this topic. Okay, next step is to do some question here. Okay, look at this question. Question 1. Well, have a look at this question. well, what you have to understand from the question is to show the relationship between the letter x and the velocity. Okay, x and the velocity. In reminding the formula that we just learned about a few minutes ago, so this acceleration can be replaced by this or this or this formula. Okay, look at this one. The first, this letter, okay, is v and x, but look at the first one. The first letter, okay, sorry, the first formula is regarding to the velocity and the time. But this is regarding to the velocity and the displacement, okay? What about second one? Velocity and the displacement? Yes, it is. What about the third one? Velocity and the displacement? Yes, it is, okay? So while you cannot use this formula, but you can use one or the other. Understand that? So this is the way how you can identify, which formula that you can replace to the acceleration. Understand that? Because this is a part of the question. So we have to do something with this acceleration. Okay, makes sense? So try to understand. Okay, so this is the key skill for, for the topic of the basic dynamics as a part of the mechanics. Okay, so let's move on here. Okay, this acceleration is replaced by the second formula. Okay, over here, it's simply replaced by that. Then what I like to do is to kind of consolidate, the letter v to the left-hand side completely. See here, v. So what I did, I moved this 1 minus v squared down to the denominator. Can you see? And then dx is moved to the right-hand side. So that's simply what I did. It's not really a great work, but it's just simple work. Why we do that? We're going to integrate them. Okay, I'm going to integrate them. Why do you have to integrate it? Because this is what you have to show, but we have the dv or dx. So we have to integrate to remove those two derivatives. Can you see this? So we integrate this one. How we integrate this? See here. So this v. Okay, but we need to make negative 2v because when you differentiate this, it will be negative 2v. So what I like to do is say fx, f dash x. Okay, so differentiate divided by not differentiate will be the log fx here. Can you see? Of course, plus c. So here, so we need to, when you differentiate this, it will be negative 2v. So we should have negative 2v up there, okay? In doing this one, well, there used to be 1. So we need to synchronize them in making, we have a minus, we should have extra minus to make everything positive. We made 2, we divided by 2. So basically nothing happened. But we achieved the goal what we want, which is differentiate divided by not differentiate format, okay? So do integrate. So negative half is negative half, so nothing changed. While this is integrated, okay, as per the formula like this, and integrate of k will be kx plus c. How do you know x? Because this letter, okay? So now, make kx the subject, okay? Kx the subject over here. So there, then all you need to do is divide everything by k here. Can you see? So the first part is exactly the same plus any constant. Well, this is a constant. C is the constant, which is the value isn't changing all the time. It's an integral constant. K is also constant, kind of coefficient and everything. So this is a constant. So this is what the question 1 asks us to do. Okay? How do you feel, guys? Yes, it should be quite easy. Okay? Again, it should be easy as long as you can remember those 3 formula, which is the candidate for replacing the acceleration. Okay? Move on, question 2. Okay, question 2 asks us, okay, the question 2 explains us something. Initially, what is initially? Initially is a t equal to 0. Does not mean x equals to 0 all the time. A particle is traveling in a straight line with the velocity v meters per second. Well, see here, that's capital velocity, the capital V. Okay, capital V is usually the initial velocity or projection velocity at the projection or something. Okay, origin. Yes, this tells you about x equal to 0. Okay, so what I like to do initially t equal to 0. Initial velocity equals to velocity. When t equals 0, velocity was capital velocity. From the origin, x equal to 0. Okay, so this is the kind of interpretation. Okay, from English language to the math language. Okay, now next one, the particle is slowing down. Well, okay, look at this one. The particle is slowing down. Okay, it is slowing down, which means negative acceleration. You have to understand that. The particle is getting faster than positive acceleration. Okay, you have to understand a particle is slowing down is represented by negative acceleration. Okay, we're going to use this one. A rate proportional to its speed. Okay, so what you need to do here, and then I'll explain a little later. Find an expression for the velocity v and x. Okay, so v in terms of v and x. Okay, so have a look at this one. The particle is slowing down. Okay, this is the acceleration. Should be negative value. We just assuming k is positive, so we ensure this whole value should be negative. Okay, and then how do you know kv? Kv is coming from a rate proportional to its speed, kind of proportional. Okay, so velocity is proportional. Okay, so what is proportional here? So the k is the proportional constant. Okay, proportional coefficient. Okay, so we learned this one in about year 8, rates and ratio. Okay, and then as per we did in question 1, this acceleration should be replaced by v dv dx. Why? Question is asking us the relationship between v and x. So v and x is there. So that's why we replace acceleration by this one. Okay, makes sense? Then, okay, so have a look at this one. Our answer should be written, say, somewhere around here. Velocity is blah, 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 x. So this is the kind of format you should get at the end of the working. Okay, don't get lost, guys. So what I do here, okay, I cancel v and v. Great. Integrate, okay? So integrate in terms of x, so velocity is integrated, negative kx. Then how you integrate it? Negative kx plus c. Okay, all we need to do now is to find the capital C, which is an integral constant. How do you know? We use these conditions over here. So t equals to 0. Oh no, we're not going to use this one. So there's nowhere to put it in. And velocity, yes, velocity. This will be capital velocity. When x equals to 0, this will be 0. Okay, sub it in. Okay, we have here. Okay, well that there I have there. So sub that in. So capital V equals to minus k times 0 plus c. So c will be just capital V. So take this back to here. Then we have the desired answer. Okay, so have a look at the question again. Find an expression for the velocity, which is v, in terms of v is blah, 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 blah. Oh, there's x. Okay, this is the constant, k is the constant, x is the displacement. So we want, we get what we want to. Okay, so that's question 2A. We'll have a look at the next one. Find the velocity of the particle after t second. Yes, find the velocity. Okay, find the velocity after t second. So this question asks us to find an expression v in terms of t. Okay, so have a look at this one. This is what we had previously from the question. So have a think about what do you want to replace this acceleration by, which formula? V and t. It must be dv divided by dt. Remember the first formula of the acceleration stuff? So we have to, this is skill. Okay, if you can do this well, you will get definitely above half those scores. Okay, now it's easy now. Okay, what are you going to do now? Okay, as I spoken to you last time, make the consolidation. So v, I want to move all of the v to the right hand side. Okay, all the v to the right hand side, and everything else should move to the left hand side. Okay, see here, v moves to here, and this v divided by that, so it comes here. Make sense? integrate both sides. Okay, integrate both sides. Now minus k, okay, equals minus k plus something, that will be log. So it will be L minus kt equals to log v plus c. A lot of people ask me in the class, well, we integrate this, so there must be plus c. Why didn't you write the plus c on the left-hand side? Well, the question is not bad. However, if you plus c, you can cancel it, so no plus c at the end, which is even worse. What you should do, if you want to have c and c for both sides, what you have to do, kt plus c something, ln v plus c something. Okay, they should be different c's. Then when you move over, equal to ln v plus c2 minus c1, then this will be just one other c. Okay, we are not interested about these individual c's, but we just know this is a kind of constant number. Okay, we just reserve a room to where any constant number be in. Okay, that's all we need to do. So this is a big mistake. A lot of things see, oh, we can cancel. It's great, easy. No, you won't get the right answer if you do it. Okay, so that's why I wrote only one c on any one of the sides. It's completely okay if you do so minus kt log v and plus c this side. This is okay. This is fine. So one or the other, not for both. Okay. Now we use the initial condition. Now we can use these two conditions over here. Okay. So initially velocity was a capital V. Okay. So this one in here, what do you see? Can you see? I just simply substitute t equal to 0. Small v is replaced by the capital V. Okay. Well, of course, that's equal to 0. So c equals to negative log v. So next step is to put this one back into here. Okay. Put this one back into here. That's the answer. Almost the answer. I mean. Okay. Okay. Now, usually at this time, students normally forget what they do. They're working very hard, but they don't know where they go. So this time, okay, if you think about that, get back to the question, read the question again. So find the velocity. Oh, okay. So what do you need to do? Our target is this one. So find the velocity, blah, 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 t. This is what we need to make. Okay, this is kind of the skeleton. Okay. So yes, we have a small v. This must be the subject of the answer. So we need to take this out. That's what you have to do. Make sense? Okay, move over here. So minus kt, okay, we make a single, say, log minus log is v divided by capital V, okay? It's a property of the log. And then, what I did is change to the index statement by the use of the exponential. So we're going to make v equals to multiply by that. So that's the expression for the velocity, see, in terms of the t. Okay? So this is what we want. Easy? Pretty easy. Pretty easy. Part C, okay? Find its displacement from its initial position after t second. So, displacement, that's x. And this is the time, which is t. Okay? Okay, have a look at this one. Well, this is the answer for part A. This is the answer for part B. So what you need to do is answer should be x equals to blah, 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 t. Okay? So again, v the same, we can equate them. Put them in. Okay, so we can equate this. And then, okay, look at this one. So x must be the subject. So make x the subject over here. And then divide by k. That's the answer. That's too easy, guys. Okay, so that's the at the end of the very first part of the mechanics. Okay, I'm pretty sure you guys have a good feeling about this one. So, I mean, if you think still very hard, then I suggest you to go back to kind of 3-unit motion, which called the application of the calculus to the physical world. You have to do that because that's the prerequisite. Okay, and if you're okay about this 3-unit topic, then come back and watch this video again. Then you should be quite okay. Okay, so next topic will be a little more than this one, but we're still using the similar formulas with the acceleration. Okay, so hope everyone is okay. So guys, stay tuned. I will see you at the next lesson.